All right. When you watch the video, though, you'll hear my voice get loud and then quiet, loud and quiet. That's just depending on where this thing is. All right. So I think the beginning is just some definitions that you guys need to know. Oh, the calendar. I think we're pretty on point. I haven't gotten behind yet, so I'm pretty happy with that. I wanted to clarify. I believe we're actually going to work on IA1 tomorrow, and I'm going to change this day to IA2. That'll be when I actually discuss IA2. So that was the only reason I put the calendar up. All right. So basic definitions. Element. An element inside a matrix. Oh, Mr. Ish. There we go. So if I have a matrix and I have something like 2, 4, 5, 0, 1, 5, or that's a 3. An element is literally a value inside, so this would be considered an element. A row. Your rows are going across. Your columns go up and down. So this guy has 2 rows. And then 1, 2, 3 columns. And the only thing you really want to remember, the way that we name a matrix, its size is row by column, and it does matter. You want to keep your rows first, columns second. Okay? So basic stuff about a matrix. And then from there, we'll do some basic adding and subtracting. Adding or subtracting, your order matters. You go exactly in the order that they ask you to. So, things to know. Adding or subtracting only if dimensions are equal. So, if I have a 2 by 3 like we had a second ago, a 2 by 3 matrix, I can add it to a 2 by 3 matrix. That's it. You can't add it to a 3 by 2. So, adding or subtracting, I don't feel like I need to do a big example for this. In this case, you just do element by element. So, literally, if I show all my work, my first element would be 1 minus 2. My second element would be 5 minus negative 3. My third element down here would be negative 3 minus 4, and then this element would be 5 minus 5. Piece by piece, element by element, okay? So basic stuff, adding or subtracting. Scalar multiples is the other thing that I don't put up here, but if there's a big old 5 in front, then the whole matrix would, the first matrix would be multiplied by 5, okay? All right, let's see, order matters. Find C if we're multiplying A times B. I just wanted to show you in terms of how you're allowed to multiply, so you don't need to write down the whole question. Multiplication is also specific, so adding and subtracting, the rows and columns have to be exactly the same amount of rows, the same amount of columns. When we multiply, if you look here, this is 2 rows by 3 columns, and then this one is 1, 2, 3 rows by 4 columns. And when you multiply, these must be equal for multiplication. If they're not, then you don't even waste your time. They physically cannot be multiplied. So if you ended up having a 2 by 3, and then let's say another 2 by 3, and they say, oh, I want you to actually multiply these. You can't. Okay? So because these are not the same, they can't be multiplied. So that's the only major thing about multiplying, and then we're going to physically multiply. Okay? You have to be able to multiply by hand, and then you also have to be able to use the calculator. Is there anyone in this room that has no idea how to input matrices into their calculator? Okay. So if you take out your calculators, go ahead. I'll show you where they go. So we'll do it by calculator first, and then I'll have you do it by hand second. So you'll figure it out pretty quickly. I'll show you where it is, and then from there you probably can do most of it yourself. But you should be able to figure out where the matrix button is. I believe it's second something. I can't remember. Someone yell it out. Oh. Second x to the negative 1. Okay. So where all your matrices are, one more hide. There we go. All right. So second, x to the negative 1. So this is where all your matrices are. If you want to input your physical matrices, you got to go to edit. If you want to use the name of a matrix to add, subtract, multiply, divide, find a determinant, that's this column. And then inside of math is where you'll find determinant of, which you will end up using. So if you want to find the determinant of matrix A, then you would have to use that button to do so. Okay? In terms of us, we won't use any of the other ones. Pretty much your matrices section is pretty short. You have to be able to add, multiply, find an inverse, find a determinant, and be able to solve equations with it. All right. With that said, Luke and Janelle, is that good enough for you guys to kind of be able to play around with it? Okay. Alrighty. So then we're going to actually do some multiplication. So let's do matrix A is equal to, actually, I guess we can just multiply. Oh, that one's really long. Let's not do that one. Let's do a much easier one. We'll do 2, 5, 3, 4. Multiply by matrix B, which negative 1, 0, 4, 2, negative 3, 5. Random numbers that I'm picking. All right, so I'm actually going to show pretty much all my work here. This is a 2 by 2. 2 rows going across 2 columns. This is 2 rows by 3 columns. So because these are equal, then I know I can multiply them. And then the other thing that's helpful, the actual size of your final matrix, your answer matrix, will be 2 by 3. The leftovers, that'll tell you how many rows you'll have and how many columns you'll have. So I know, and I'm going to just do this so that people that aren't here kind of get a better idea of what we're doing here. All right, so I know I'll have 6 elements total. All right, and then the way that you physically multiply, you take the first matrix is considered your row matrix, and then the second one is kind of like your column matrix. So what I mean by that is, if you want to find, and I'm going to actually go out of order purposely, I want to find the answer to this element. To do that, that would be row 2, column 2. So to find that specific term, I would take the second row and the second column. And being able to do that is important, understanding how to find each term. So what actually goes in there is you physically turn your row to match up with your column. So the numbers that I would have next to the columns would be 3 and then 4. So my row got turned into a column. And then the math that you do would be the 3 times 0 and then plus 4 times 3. So the ones that are next to each other get multiplied. The ones that are next to each other get multiplied, and then you add. I'm going to erase that here. I'm going to put back the 0, 3. And then same thing here, I'm going to put back. So with that, you should be able to, I think what's 3, 4? You should be able to fill out all of them. So now we're going to go in order. I'm going to take the first row, which would be 2, 5, multiplied by negative 1, 2. So 2 times negative 1 plus 5 times 2. Anyone confused on where those numbers are magically appearing from? Okay, because then I'm just going to finish it off then. Second one would be first row, second column. So it would be 2 times 0 plus 5 times 3. The third one would be first row, last column. So 2 times 4 plus 5 times 5. Bottom row, first column. So 3 times negative 1 plus 4 times 2. And then the very last one here, I'll do an orange, 3, 4, and then last column 4, 5. So 3 times 4 plus 4 times 5. And then you get your 6 terms pretty easily. I'm not too worried about the final answer. I'm going to assume that you guys can add and multiply. Pretty good assumption, I hope. There's no fractions, and there's some zeros. A little helpful. All right, any questions on how to find where the terms go, where your elements go? All right, just make sure you know if they can or cannot multiply. You want to be sure that you can find the terms because there may be constant values thrown in there and they ask you to solve for k, and k will be, say, sitting here, and they'll give you some type of problem where you might have to multiply and you won't have to do the whole matrix. You'll only have to use specifically the one that has k in it. So I want to make sure that you can find your terms. All right, matrix multiplication, done. All right, identity matrices, you don't have to write down everything at all. It says if there's a matrix, call it A, and you multiply it by the identity matrix I, you're just going to get back your matrix originally. That's essentially what it says. And your identity matrix is always a square matrix, and your square matrix meaning 3 by 3. The identity matrix has zeros everywhere except for along the on this one diagonal. It's always ones going all the way down. Okay, so that is your identity matrix. If I wanted to do a 2 by 2 identity matrix, 1, 0, 0, 1. If I wanted to do a bigger one, let's see, oopsie, that should start with a 1. Depending on how many rows and columns I want to do, that'll determine how many ones I have. So if I do 4 of them, then that means I'm going to have 4 across and 4 down. And then fill in the rest being 0. So that's your identity matrix. Identity matrix does exactly that. You multiply any matrix by it, and you'll get back your original. All right. See, inverse. Inverse is also important. Show that these are I can't say it. Someone help me. Thank you. That works. All right. So I want to make sure that you guys can multiply in terms of getting inverses on top. An inverse will essentially undo in a sense. So if you have a matrix A times B, and then that is the same as B times A, then both of those have to give you the identity matrix. So the order of multiplying forward, A to B, and then the order of multiplying backwards, B to A, they both should give you the identity if they're inverses of each other. We're actually not going to do this specific problem. I actually want to first start off with just finding inverses, knowing I wanted you to know what an inverse is. So the fact that A times B will be the identity, and then B times A will also be the identity. That's the definition of an inverse. I'm going to have you find an inverse, which includes determinants, and then from there we may solve that if we have time. I think we do. All right, so starting off. Well, actually, maybe I'll have you start off there. Go ahead and multiply A times B and B times A. Prove that they are multiplicative inverses. I said it. Yay. So do that first for me real quick. I think I've actually specifically seen this on an IB test where they've actually asked to prove it, and then people didn't know what the definition of a inverse was, therefore couldn't prove it. While you guys are working, I'll finish it off also. So 7 times 3 plus 5 times -4. 7 times -5 plus 5 times 7. 4 times 3 plus 3 times -4. And then 4 times -5 plus 3 times 7. All right. Any questions on how to find the terms? Because I do believe we get 21 and 20 in the first. We get 0, and then -20 and 21, so we get 1. All right, so they're definitely inverses of each other. If you get a problem that asks you to prove, proving is different than finding. If they ask you to prove that these are inverses of each other, then you need to physically multiply them out, A times B and then B times A. All right, so now we're going to actually find how to do an inverse. So we'll just take matrix A, and the next, I think yep, finding an inverse. All right, so the inverse of a 2 by 2 has a formula. and then I'm going to show you how to do a 3x3 because in all honesty, I can't remember if you need to be able to do a 3x3 by hand or not. And just because I can't remember, I'm going to force you to be able to do it in case it shows up. So the inverse of a 2x2 is always the same. It's always 1 divided by the determinant of that matrix, multiplied by, you're going to switch the order of these two, and then these just become negative. So given that the matrix is A, B, C, D, so that's the original, the determinant would be, the inverse would be 1 divided by the determinant, multiplied by the matrix, switch the order of these two, and then these B and C only have negatives in front of it. So that is physically how to find an inverse. So then the determinant is 1 over multiply A times D, and then minus B times C, and then here's the full formula of finding an inverse. This bottom part being the determinant itself. So, I'm going to do this in a 2-part just to make sure you know how to find the determinant value, because that could be a question. The determinant value will physically be AD minus BC. So A, 4, D, 5, minus 3 times 7. So that is physically the determinant. And that gives us, I believe, -1, right? All right, so there's my determinant. And then to find the inverse, call that A. Inverse would be 1 divided by -1 multiplied by, switch these two, 5, 4, and then multiply these by a negative. And then multiply that through. So I'm multiplying by -1, and I believe we get -5, 7, 3, -4. So you have to be able to find the determinant of a 2x2, find the inverse of a 2x2, and then use it. Okay? So the next problem will be us solving a system of equations using matrices. So this is something that's really important. So on your IB test, if they physically give you a system of equations and it's within a matrix problem, you only get credit by doing it in the method that they ask. So if they say, solve this system using matrices, and you go and solve it by elimination or substitution or by graphing or by guess and check, any of those methods, you won't get any credit. It physically says that in the scoring guide. No credit for any other type of solution. Okay? So this does show up pretty often, being able to solve using matrices. So the key is, if it's a 2x2, you can also do a 3x3. If it's a 2x2, you want to label your matrices first. So matrix A is your coefficient matrix. It's the coefficients of all your terms. Notice that it is in standard, that's +1, in standard form, meaning AX plus BY. So that's your A matrix. Your B matrix is the 3, 4. Okay? And then your variable matrix is XY. So a lot of times they just call it X. So I did do it a little bit out of order because I like having my A and B together. But the actual matrix equation is physically, if you multiply matrix A by matrix X, you should be getting matrix B. That's the physical equation. So how does that work? How do you get your matrix X? You multiply on the left. One thing that you might not remember from learning matrices have an order, and you have to follow that specific order. So what I mean by that is, on this side of the equation, if I multiply by A inverse on the left side, then I have to multiply B by the left side A inverse. So squeezing in right there, I'd multiply by A inverse here. So they have to go in that same order. In normal equations, we don't really care about multiplying. There's no physical order. 2 times 3 is the same as 3 times 2. In matrices, it does matter. If you multiply A times B versus B times A, you will most of the times get a different answer unless they're multiplicative inverses. So once we know that, then I know that to solve for matrix X, I would take matrix A, find its inverse, and multiply it by matrix B. So that's the math that's involved. 2 skills we just did: finding an inverse and multiplying. So you're able to do both. So let's go through, make sure we can do it. The inverse of A, so here's A, would be 1 over the determinant. The determinant is multiply these two. 2 times negative 1, which is negative 2, subtracted by 3 times 1. To physically make the inverse, then we switch the location of A and D, so 1 and 2, and then the other two numbers, you just make them negative. So there's that piece, and then I'm going to just put in my B matrix over here, 3, 4. So the ones that I'm physically going to be multiplying, I will be multiplying, and that says negative 1/5. So negative 1/5, positive 3/5, positive 1/5, and then negative 2/5. Hopefully I did that right. Multiply by 3/4. So when we're all said and done, it should give us the physical solution to that equation. It will give us the point that the two lines intersect, so that's one way of looking at a system. It will physically give us the solution for x and y that makes both statements true. So let's finish it off. Make sure we can do this. So this multiplied by this guy, right? Yes? Would it be? So D is this one. Negative 1 times negative 1/5 makes positive 1/5. Where am I? Uh-huh. Oh, no. Yeah, you're right. Which would turn that positive. You got it. Thank you, sir. All right, we're good? Oh, sorry if you went fast forward and finished it already. Okay, good. All right, so the first term, we get 3/5 plus, what is that, 12/5? And then the second term, which would be, I'll do in green, so this one multiplied by this guy. So 1/5 times 3, so 3/5 again, minus 8/5. And then you get 15/5, which is 3, and then you get negative 5/5, which is negative 1. Hopefully that works. Let's see if it works. So I should be substituting in 3, negative 1. So 3, negative 1 equals 3. Perfect. All right, and then the other one is negative 3, negative 1 equals 4. Yep, so the solution works. That's how you would check your solution. It would also mean that 3, negative 1 is the physical point where the two lines would intersect. All right, any questions on that guy other than my mistake? All right, last thing that I want to do is a determinant of a 3 by 3. I think that's the only thing left because I can't remember if you have to do it or not. All right, and I'll be nice. I'll put a 0 in there, here and there. Let's do 1, 5, 2, 0. That's not a 3 by 3. I need more space. All right, 0 to negative 1. 1, 3, 0. It makes life much easier if there's zeros in there, all right? So there are two different ways to do a determinant of a 3 by 3. I am only going to show you one way because I think it's easier. You take the first two columns and repeat them. There's column 1 and there's column 2. Repeat those two. Okay, so that's step 1. Repeat the first two columns. And then you will physically add going forward. So what I mean by that is, in a diagonal, this would have a plus sign, this would have a plus sign, and this would have a plus sign. And then going the other way, let's use blue because I didn't use that color. You're going to start from the back and go this way, and this would be a minus, and a minus. And then it's going to look like a hot mess. So that's the setup. If you can make that picture happen, you pretty much have your determinant. So how do you find the physical determinant in red? I would do exactly what it says. I'm going to take the 1 multiplied by 2 multiplied by 0, and then you're going to physically add the next one. 5 times negative 1 times 1. Add the next one. 2 times 0 times 3. And then all the others in blue, you're going to subtract them. So subtracted by 5 times 0 times 0. Subtract, what is that, 1 times -1 times 3, and then subtract 2 times 2 times 1. It's kind of a long process, but the mathematics behind it is pretty easy. And the zeros in there makes it a lot nicer. So 0 minus 5 plus 0 minus 0 plus 3 minus 4. That's nice. -1, -6, I believe. Yep. So those are the basic skills that you need to know, and then you're going to do physical problems that incorporate those skills. So the problems do get slightly harder. They're not just going to say, multiply these two, just do this. You'll notice that the IB problems just kind of have a lot in them. Because your quizzes can only be 45 minutes, you won't see as many in the beginning of the very long problems. But you get like 2 or 3 long problems at the end of each paper. All right, for those of you that are still awake. Questions? All right, if not, I'm going to turn this guy off and then we can talk a little bit about dry A's.